Hello, eighth graders. Today we're going to do um, maybe more of a real world type problem. And I just want to give you an example of something similar to get you started. Then I would like you to look at the sheet of paper that I have for you today. And from that sheet of paper, listen carefully. You are going to make posters that explain what the problem is that you're working on, shows in quite a bit of detail what you did to solve the problem you're working on, and explain as you go along. All right? Because I know you all love to explain your math problems, but that's the purpose of math classes, is really to sit down and not just come up with answers, but be able to explain how you got your answers. Let's look at a problem that I'm going to call the hat problem. Suppose that I have, some kind of a team, could be a baseball team, maybe a football team or something, and we decided we're all going to get hats for our team, and I'm looking at prices. And in order to get the hats made for us, one company says they would be happy to put our favorite emblem on our hats and manufacture those hats for, let's say, $15 a piece, which is a pretty good deal. But each hat that we buy is going to cost us $15. Okay? Okay. Can we write an equation for this? Yeah, we can. And I want you to think back as we're doing this, because we're working with linear equations. We're going to be working with them for a while. And remember from the last chapter, you just took a test on this. I haven't gone through those, but I'll look at them, get them back to you next week. But a linear equation can be put into the form y equals mx plus b, where m, again, is your slope. You're just not going to get away from this year. You're going to be doing this over and over again. And b is your y-intercept, right? That's your y-intercept. And we said our slope is our rate. We called it a rate of change. And we called our y-intercept our initial value. That's where we start. So thinking about this and putting it into like y equals mx plus b form, is there an initial value that I need to pay to get my hats made? The answer is no. They're not charging us any initial value. They're just telling us, hey, for each hat, we got to pay $15. Okay. I can write my equation as sort of just y equals 15x plus nothing. Okay, my initial value is nothing. I don't have to pay anything up front or initially. I'm just paying $15 for each hat. That is my rate of change. That's the rate they're going to charge me for each hat in y equals mx plus b form. This is y is equal to 15x plus nothing. But I would be remiss if I were to say, oh, yeah, just go ahead and make those hats and go with the first company that I call. Suppose I want to get the best deal, and I call at least two places. The second place tells me, well, there is a setup fee. We charge $50 to set it up. So you give us your emblem that you want on your hats, and we'll start making hats for you, and we charge you $10 per hat. Let's stop and think about this in terms of y equals mx plus b. Before we even start, they said there's a $50 setup fee, and so that's really going to be my initial value, my y-intercept, isn't it? So if I was going to write an equation for this one, I can say y is equal to blank x plus blank. Remember, we were doing that in the last chapter with our initial value here as 50. They're going to charge us $50 before we even start, just to set things up. And then they're going to charge us $10 per hat. So the question becomes, I wonder which one I should go with. This is a real world kind of problem. You see this kind of stuff all the time. I've purchased a lot of uniforms and shirts and hats and such for the school. And this is kind of the way that companies will charge. You'll have one company that just charges a flat rate per item, and you'll have another company that wants to charge a setup fee and then charges you a different fee per item that you purchase. However, you'll often find that these companies that charge initial setup fee, their rate's a little bit less. That is that per item, you pay a little bit less, but you got to pay a little bit more up front. Which one would be a better deal? Well, it really sort of depends on how many we buy. Some people, when they've done problems like this, choose to make some tables. That would be, you can make a table and say, oh, well, I'm going to put my X and my Y in here. And we can use our equations. The first equation, we're really just going to take 15 times whatever X value you put in. So you can start your table off and say, well, for one hat, it costs $15. For two hats, it costs $30. For three hats, it's going to cost $45. We're just going to add 15 in each time, or maybe a better way of saying that is we're going to take our X value times 15 each time. 1 times 15 is 15. 2 times 15 is 30. 3 times 15 is 45. And we can continue to do that. We can make a table of values for our other function as well. To get one hat, we have to first pay $50. And then they're going to charge us $10 per hat. So I got to pay my 50 plus 1 times 10, which is going to give me $60 for one hat. 2 hats are going to cost me $70. 3 hats will cost me $80, and so on, because there's an initial fee of $50 plus you're going to take this number times 10 and add that on. So, for example, if I say 4 hats, I got to spend $50 plus 4 times 10, which is another $40, and 40 plus 50 is going to give me 90. Again, I'm just using this equation, plugging in this number for X. 10 times 4 is 40, plus that 50 gives me 90. Okay? And so I could continue to do this. Initially, you're going to think that you'd be crazy not to go with, not to just not go with these people. But I'm going to say that eventually you're going to reach some number of hats that you want to buy where this company is going to actually be cheaper. Because this one's growing by 15 every time, and this one's only growing by 10 every time. I don't know when they meet. It could be at 10 hats. It could be at 20 hats. I don't know. Somewhere down the road, this company is going to be cheaper. It could be at 100 hats. Who knows? So the real question then becomes, well, when are they going to be the same? When does this company become cheaper and this company become more expensive? Because it's quite clear that when you're not buying very many hats, this first company is way less. But as you go on, you're going to find out that this company is actually going to be cheaper for more hats. If you buy a lot of hats, this company is going to be cheaper than this company. If you don't believe me, carry these tables out. Or what we could do, and I kind of like this idea, is we could graph. We learned how to graph before. Yes, we did. So I'm going to make a graph. Whenever I make graphs, I use a straight edge to make my lines. And we should give this a label. I'm going to call it hat costs. And the axis down here is going to be the number of hats. And the axis on the side is going to be our cost. And this is in dollars. One, two, three, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. I can count. 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, and go out here in 25. All right. Now our cost, I don't think we're going to go by ones here. That wouldn't make much sense, would it? Our cost, and I'm just looking here, the smallest number that I need to plot is 15. If I were to plug, because I can go out here to like 25, somewhere up here is like 25. If I were to plug 25 in there, for this company, it's just 25 times 15. It's 375. Let's see what happens in this company. 25 times 10 is going to be 250 plus another 50. Makes this one 300. So, like I said, for this first company, somewhere before you get to 25 hats, they start charging you more than this company, because I can get 25 hats from company 2 for $300, and from the first company, 25 hats is going to cost me 375. So they did flip flop somewhere, and I'm not quite sure where, but let's say that I go out as far as 25, I got to get up to 300. 16. That's like 15 there, right? So if I have 15 lines, I can say, well, I needed to get to 375. 375 divided by 15, it's about 25 per line here, right? So I can say 25, 50, 75, 100, 125, 150, 175, 200, 225, 250, 275, 300, 325, 350, 375. Did I count all the ones I wanted to? 400. Hopefully I didn't miss one. All right. So let's plot some points here, see what we got. On my first one, let's go 115, 1 and 15. Half of 25 would be 12.5, right? So it's going to be a little more than half. It's got to be up like there. I was trying to cut like thirds here. I think 115-ish is going to be around there. And 2 hats were 30. That's not too much past there. So 2 hats were there. If I've done this accurately enough, I do believe. Oh, and by the way, 0 hats is 0. Then a line that would represent this situation, this first situation, as I plotted some points and drew my line, looks like that. Let's see if I can get my second line. At 1, we were at 60, which is about yay. Right? At 1, we're about 60. And I'll do a little bit further on. At 4, I'm at 90, which is just a little bit less than 100. Right? Right, they said. Also notice that I should be going through 50. Why through 50? Well, because that was my initial value. That's my y-intercept. Why did I do this, you might ask? Well, I wanted to know where it is, how many hats do I need to buy from my original thing. And again, you could just sit here and start filling out tables until you get to the right costs. But I could also look at this sort of graphically and say, well, I can make a graph, and that tells me that somewhere between 7 and 8 on my graph, that that's where it changes. Let's look at what 7 gives me in the first one. I'm going to look at 7. All I do to find the value is just take 7 times 15, right? Because on the first one, it's just 15 times x. So if x is 7, I just do 7 times 15. That's 105. Let's do 7 in my second situation. That's going to be 7 times 10 for 70 plus the initial 50. And that gives me 120. Now let's do 8. At 8 hats, I'm going to do 8 times 15. And that gives me 120. And at 8 hats here, that's going to give me 80 plus 50. And that's 130. Excuse me. So my graph was a little bit off, but it's going to get there. It's going to give me a pretty good idea because I think this is where it switches now. At 9, my original value is going to be 9 times 15, which is 135. And at 9 here, it's going to be 140. Is that right? 90 plus 50. And at 10, it's going to be 150. And at 10, this one's going to be 150. All right. So My graph, which wasn't a very good graph because it should have actually been crossing at 9. Teach me to try and use straight edges. But anyways, shows me that they're the same amount at 10. If I buy 10 hats at $15 a piece, I'm going to pay $150. If I buy 10 hats down here at $10 a piece plus 100 plus the 50 setup fee, my cost is also going to be 150. So for this particular problem, I know that if I buy less than 10 hats, the first company is the one to go with. But I know that if I buy more than 10 hats, this company down here is going to be the cheaper one. And I could look at them in two ways. I can make a table until I hit the values, or I can graph it and see where they cross and get an estimate that way. Which way you choose to do yours is kind of up to you. I like maybe a combination of both of them, but your job is going to be to do something very similar. You have to get your worksheet, right? It's called the baseball jersey worksheet. And he's going and says Bill's going to order new jerseys for his baseball team. The jerseys will have the team logo printed on the front. Bill asks 2 local companies to give him a price. And the first company tells him, well, we'll just charge you $21.50 per uniform. And the second company says, well, we'll do a setup cost, an initial fee of $70, and then charge you just $18 for each jersey. Your job is to come up with an equation for each. Use the equations to figure out which one he should choose. Okay. And it might be a situation like this where you go, well, it kind of depends on how many jerseys he needs to order, because one company is probably going to be cheaper originally, and the second company is probably going to be cheaper if you buy more. So you're going to have to figure out, well, how many jerseys does he have to buy for one company to start becoming cheaper? Okay. And then finally, the last question here says that he decides he's going to order 30 jerseys from Top Print. How many more jerseys or how much more would the jerseys have cost had he bought them from someone like Print It? I don't know. You're going to have to show your calculations, and not just on this sheet of paper, but there's 2 pieces to this. You are going to fill this out and put your name at the top, right? So I know whose paper's whose. And then you're going to make a poster with the poster paper that's back there by where I store books, right? You got poster paper back there, and there are colored markers on the counter. Posters should be colorful and neat and something that we would like to display in the classroom. So on your poster, you want to put your name as well. So you've got to put your name and your information on here, and then based on what you found on your piece of paper, and not until your piece of paper is finished should you go get your poster. So the first step would be make sure you have all your calculations on your sheet of paper. And if you did any graphing or tables, they need to be either on a sheet of paper, or you can grab some graph paper and put it on graph paper. But make sure that your papers are completely filled out and ready to go before you go to your poster. And then on your poster, you're going to be explaining, yes, I know it's already on this worksheet. That's not the assignment. The assignment in total is finish the worksheet, then transfer information to the poster and go along, so that someone who looks at your poster once it's up on the wall will be able to follow along what it is that you're trying to do, and make sure that all the information that's pertinent from your worksheet that you've already got filled out gets put onto your poster, and that your poster has nice graphics on it. If you want to draw a cool logo or whatever, if you want to draw cool baseball players, you can do that. If you want to draw a picture of what that cool jersey is going to look like, you can do that. But the main point would be make a nice poster that's well organized, gives good information, and explains in detail what you're doing and shows the steps necessary, just like you already have on your paper. And if you did any tables, they need to get onto your poster. And if you did do any graphs, they need to get on to your poster as well. Okay, you have 2 days to do this. And so what I would say anytime I give an assignment that takes 2 days is that your assignment, when you turn it in, better look like you spent 2 days working on it, because that's what's going to reflect on your grade. If you want a good grade, make a good poster. And the way you make a good poster is to fill this sheet out first completely with the pertinent information on it, and then transfer all the information you need onto your poster in a neat, orderly fashion that makes a nice poster, okay? That's your assignment for the next 2 days. Good luck. We'll see you next week.